Welcome to the Crazy Hat Chemist. So here we go, another video on kinetics. And this is a fast rate law here today. Bam! So today we're talking about a summary of rate laws. Now remember, we are going to be mainly discussing three different orders of the reaction here. And that is zero, first, and second order rate laws. So on the far left hand side, I have the order, the rate law, the integrated rate law, the straight line plot, the slope, the units of k, the y equals mx plus b, that is the linear form, and the half-life equation. Okay, so here we go. Let's see if we can do this. This is for zero order, reading from the top to the bottom. The rate law is R is equal to k times x, when the concentration, that's brackets of x, to the zero power. That zero lets you know that it's zero order. The integrated zero order rate law is concentration at time zero, that's x sub t, minus x of zero minus x of t is equal to kt. The straight line plot of this is concentration versus time, and I just discussed that on the previous video. The slope of that is negative k, okay? And then the units of k are going to be moles per liter per second. Okay, it could be moles per liter per minute as well. Okay, or any other units of time. The y equals mx plus b straight line plot form of this is x sub t is equal to negative kt plus x sub 0. And the half-life equation is t of 1/2 is equal to 1/2 x sub naught over k. Now I want you to look at that half-life equation for zero order and notice that it is dependent on the initial concentration. That is very different from the next one that we're going to do. So here's the next one, which is in the middle, and that is a first order rate law. So the first order rate law is, the rate law itself is R is equal to k times t to the first power. That's why we know it's a first order rate law. The integrated first order rate law, which I already went over, is natural log of x sub t divided by x sub naught is equal to negative kt. The straight line plot is natural log of concentration versus time. And the slope is negative k. Notice that the slope for zero order and first order is the same, like negative k. Not the same k value, but it is still both of them negative k, and that will be unlike second order. The units for k are per unit time. So it could be per second, per minute, per day, per hour. Okay? And the y equals mx plus b, that is the linear form of this, is natural log of x sub t is equal to negative kt plus natural log of x sub naught. And the half-life for this is t of 1/2 is equal to natural log of 2 divided by k. Very important equation right there. Notice that this first order half-life equation is not dependent on the initial concentration. If you have a radioactive example of any kind, you are always going to be using the first order rate law, because all radioactive samples undergo kinetics, that is a first order rate law process. So if it says that uranium-238 decomposes, you know that you're using first order rate laws and first order kinetics. So you're going to follow this middle column here. Okay, I'm going to go to the far right hand side over here, and we're going to be talking about second order rate laws. Second order rate laws, the rate law itself is R is equal to k concentration to the second power. That's why I know it's second order rate law. The integrated rate law is equal to 1 over x sub t minus 1 over x sub naught is equal to kt. Okay, the straight line plot is 1 over the concentration versus time. And the slope is a positive k. That means the slope is a positive k. That's unlike zero and first order. The units of k are liters per mole per second. Okay? All right. So that's flipped from what is zero order. I hope you see that for the moles and the liters and the moles right there. The y equals mx plus b format is 1 over x sub t equals kt plus 1 over x sub naught. And the half-life equation for second order is T of 1/2 is equal to 1 over K times X sub naught. Notice again that both zero order and second order have a half-life that is dependent on the initial concentration, unlike first order where the half-life is not dependent on the initial concentration. Okay, this is a summary of the rate laws, and this is a very important slide. This one slide, you need to memorize all the information on this here for zero, first, and second order. I can't tell you how important all this information is. Whether you graph the problem, whether you solve for the initial concentration, solve for the final concentration, solve for the amount of time, solve for the rate constant, whether you do that mathematically or graphically, this is all very important. If you are given the units of K, then you actually really know what the order of the reaction is as well. Okay, so study this slide. This is like your go-to slide for this entire unit. Highlight it. Okay, this is very important for you. Okay, I am the Crazy Hat Chemist, and here is another crazy hat for you. It's coming up. All right. Some people call me the king of chemistry, but today I am the pharaoh of chemistry. I hope you have a fantastic day. Give me a thumbs up if you like that video. Subscribe to my YouTube channel. Pass it on to all your cool chemistry friends who want to learn all the chemistry. Give me a thumbs up. Subscribe, and I'll see you next time. Bye now.